Hello everyone, you're welcome to solve this nice math problem, which is the limit of cos x raised to the power of 1 over x squared as x tends to 0. So let's provide a solution from here. Now, let m be equal to the limit of cos x raised to the power of 1 over x squared as x tends to 0. So the first step to do here, let's introduce the ln on both sides so that we have ln of m. This is equal to the ln of the limit of cos x raised to the power of 1 over x squared as x tends to 0. Now, here we have ln of m. This is equal to, now this is the limit as x tends to 0 of, now here we have the ln of cos x. This is cos x raised to the power of 1 over x squared. Now, we have that the ln of cos x to the power of 1 over x squared, this is in the form of ln of a to the power of n, which we can express as n ln of a. Applying this property, then here we have ln of m. This is equal to the limit as x tends to 0. Then here we have 1 over x squared multiplied by the ln of cos x, which we can write as ln of m. This is equal to the limit as x tends to 0. Now this is the same thing as ln of cos x divided by x squared. Now let's substitute the value of 0 here. So we have the ln of cos 0 divided by 0 squared. This is x squared, so it's 0 squared. And this is equal to cos 0 is 1. So we have ln of 1. Cos 0 is 1. So we have ln of 1 divided by 0. And this is equal to ln of 1 is equal to 0 divided by 0. So we have that this limit, by directly substituting the value of x equal to 0, this means that we have indeterminate form. We have the indeterminate form. Now, whenever we have the limit that's of indeterminate form, then we apply the L'Hopital's rule. Let's apply the L'Hopital's rule, such that now here we get the derivative of the functions separately. So we have the ln of m. This is equal to the limit as x tends to 0 of the ln of cos x divided by x squared. So we get the derivative of ln of cos x separately and the derivative of x squared. Now applying the L'Hopital's rule, we have here the ln of m. This is equal to the limit as x tends to 0 of the derivative of, we have ln of cos x divided by the derivative of x squared. Now here we have the ln of m. This is equal to the limit as x tends to 0. We have the derivative of ln of cos x. This is the same thing as minus sine x divided by, we have cos x. Now, everything here divided by derivative of x squared, which is 2x. And you find that sine x over cos x, we have that sine x over cos x. This is the same thing as tan x. Okay, we have sin x over cos x. This is the same thing as tan x. So therefore, we have the limit, that is the ln of m. This is equal to the limit as x tends to 0. Then of, we have minus tan x divided by 2x. Now, substituting the value of 0, then we have minus tan 0 divided by 2 times 0, and this again is 0 over 0. So this is indeterminate form. This is indeterminate form. So again, let's get the derivative of negative tan x separately and the derivative of 2x. So let's proceed here. So we have the ln of m. This is equal to the limit as x tends to 0. Now, the derivative of negative tan x divided by the derivative of 2x. Okay? And this means that we have the L. Now here we have the ln of m. This is equal to the limit as x tends to 0. We have that the derivative of minus tan x. This is minus sec squared of x divided by the derivative of 2x, which is 2. And now we have that. Let's substitute the value of x, which is 0, so that now we have the ln of m. This is equal to the limit as x tends to 0 of minus sec squared of 0 divided by 2. And something to note here, we have that sec 0, this is equal to 1. So this implies we have the ln of m. This is equal to the limit as x tends to 0. Now we have minus sec squared. Sec 0 is 1. So we have minus 1 squared divided by 2. And this implies that here we have the ln of m. This is equal to 1 squared. This is 1. So we have minus half. Now, the next step is that if you're given the ln of x equal to a, then to solve for the value of x here, that means that x is the same thing as the exponent e to the power of a. So introducing the exponent property, now we have that the ln of m is equal to minus half. Now to solve for m, we introduce the exponent property such that if you have ln of x equal to a, this is the same thing. X can be expressed as exponent e to the power of a. So this means that we can express m. This is the same thing as the exponent e to the power of minus half. Now, given that if you have a to the power of minus 1, this is the same thing as 1 over a. So applying this property, we have here m is equal to 1 over exponent e to the power of half, which we can express as 1 over square root of exponent e. Now, we have that exponent e. This is approximately equal to 2.718281828. And this means that the square root of exponent e, this is the same thing as square root of 2.718281828. And this is equal to 1.64872. So this implies that here we have m is equal to 1 over square root of exponent e, which is equal to 1 over square root of, this is 2.7182812828, and this is equal to 1 over, we have 1.64872, and therefore we have that the value of m is equal to 0.60653. So this is the value of m. Now, if you recall, we have seen that we let m be equal to the limit as x tends to 0 of cos x raised to the power of 1 over x to the power of 2. So this implies that the limit of cos x raised to the power of 1 over x squared as x tends to 0, this is equal to 0.60653. And this is the solution to this limit function. So kindly follow the steps, like this video, and kindly subscribe. See you in the next video. Bye bye for now.